Fucking Twitch. Are we live? Maybe we are live, but Twitch is fucking piece of shit website. Okay, we're live. Hello everyone and welcome to yet another recreation and programming session with Mr. Tsoding. We're gonna make a cup of tea. We're gonna make a cup of tea first and then we'll probably do something. Alright, so I'm gonna shuffle OGG and yeah. Alright, so making a cup of tea. Okay, so I'm gonna be steeping the team. So for 5 minutes. Alright, how's it going, everyone? How's it going? Hello. Yeah. Anticipate an hour stream. Well, depends on the goal. We'll see. Depends on the goal. Let's show a triangle. We're probably not going to be doing triangle. The goal is more of a compute shaders, so I'm not sure if we'll even need a window. We'll see about that. For the game, no, not for the game. Why you sound so tired? Because I am. No triangle. I'll see about that. We'll see. Maybe we can compute a triangle in a compute shader. Who knows? Who said we can't do that? It's been a minute. How have you been? Yeah, I'm fine, I think. I lost a note somehow. At the post note, but then somewhere, maybe it fell somewhere. Fuck. Alright. I have to find it after the stream. I'm not sure if I'm gonna be porting soon to Vulkan. I'll see about that. We'll see about that. Can you make a DSL that compiles to Vulkan? I probably can, but I'm not sure if I will, because I don't have a use for that. I can't make a content out of that, at least a quick content, because it's probably gonna take way more than 1 or even 2 sessions, so it means it's not marketable. So not gonna be doing that for content, not gonna be doing that for myself in the nearest future. So yeah, so I probably can, right? So because it's basically taking a text in a programming language and compiling it to some sort of bytecode, but there is no incentive for me to do that, even a single one. Are you interested in Godot? No, I'm not interested in Godot. Will you make a session trying it? Probably, if I need to do a slope extreme to prop up my numbers. But apart from that, I'm not interested in Godot. In fact, I'm not interested in using any engines. Right? So if I want to make a game, I just make my own engine, or a small subset of an engine, specifically to run my game. I may try it purely for entertainment purposes, purely for the content, but not for myself. I for myself don't see a use for Godot, at least yet, right? So maybe I'll have a use for that. We'll see. So thank you so much, Surprising, for the sub with a message. Hello. Have you heard about Pico 8? I heard about Pico 8. I don't know what is a Picotron. Which is what you're doing. Not really. Actually, I want to specifically learn Vulkan compute shaders. Alright, so I want to have some sort of a way to do compute shading on my setup. Right, so I don't know a single way to do that right now. And I want to discover it. So I'm kind of partially doing that for myself. Right. So it is a nice content that I can put, Vulkan in C, and everyone, holy fucking shit, numbers go. But at the same time, there is also a very useful aspect of me of discovering a new tool in my toolbox. You know what I'm saying, right? So there's like, it's not always like a, engagement farming, right? So my channel is, I would say, half of the engagement farming, and half is actually self-improving. Right? So that's how I can describe my channel. Half engagement farming, half self-improving. You can also draw using compute. Of course you can. Like, I mean, even if you think logically, right? So can compute output array of bytes? That's it. You can draw. Like, you can draw into an array of bytes, right? It doesn't matter whether like there is technical possibility. No, can you output array? But there you go. You can draw. So I don't remember who, but somebody said long time ago. I think when I was oh, here is the post note, by the way. When I was a teen, so I read that in some book or whatever. If you can put a single pixel, you can make Doom. So it's literally the same situation. By the way, isn't the sound buffer also an array of bytes? Exactly, you can generate sounds with compute. It's just like everything is bytes. Everything is bytes. So if you have a buffer of bytes, you can do anything. It's just a buffer. Yeah. Are you bytes? I can bite you, chat. So be careful. So thank you so much, X. Oh, there were more. Hue Saturation 1212. Thank you so much for Twitch Prime, and X Snackage X. Thank you so much for tier 1 with the message. Everything is computer. Exactly. Everything is the latest thing that humanity has discovered, right? So is that what it is? Everything is a LLM. Anyway. Oh, well, I'll bite you. Okay, so let's start maybe, coding. So should we use VK byte? Kamikaze suggested to look into VK, not VK byte, but VK guide. Right. So should we look into that? As far as I know, there was a Vulkan tutorials as well. Vulkan tutorials. Let's actually see if we can even open them from Russia. Is it allowed in Mother Russia to use? Okay, it is allowed in Mother Russia. Thank you, Vladimir Vladimirovich, for allowing me to learn Vulkan. I really appreciate that. Anyways, hello everyone, and welcome to yet another recreational programming session with Mr. Azozin. So today I decided to learn Vulkan in C. Some of you probably know that I already did a Vulkan stream in Rust. Here is the catch. I do not remember shit from it. Because what I did, I just followed the tutorial and I got the cube at the end. And I said, hey, I did it. And that's it. I forgot everything. And yeah, so today I have a rather specific goal of learning Vulkan, right? So I want to get into compute shaders, right? So I want to have a way to do some sort of a way to do compute shading on my setup, because as of right now, I don't really know any way to utilize my GPU for general purpose computations. And yeah, I just want to have one. I tried to do OpenCL and that didn't work well. It didn't work. It worked out so badly that I didn't even post the VOD. So, and yeah, so I heard that Vulkan for compute shading works great, and that's going to be the topic for today's session. We're going to try to learn Vulkan and see how we can utilize this stuff for compute shading. Sounds good? Sounds Gucci? Sounds what? Tamaguchi? Let's fucking go. To be fair, so here we have Vulkan tutorials. I was also suggested to look into the VK guide. All right, so all of these things are going to be in the description, right? So this is the stuff we're going to be using. Maybe we could use some clankers, but I don't really want to use them extensively, right? So because then they may confabulate some shit and I have to verify that. I'd rather read the original source, right? So from which the clankers were learning stuff. Okay, so there is a tutorial, there is about this tutorial, there is a wall of text, they describing something, so I'm not sure if I want to read that. So let's take a look at the overview. Is there something interesting? So, original look of what it takes to draw a triangle. To be fair, I'm not really interested to draw a triangle, right? So I'm interested in compute shading, and somebody told me that for compute shading, you don't even need a window, unlike in OpenGL, right? So OpenGL context, if I remember correctly, always requires a window, and that's why it's kind of difficult to do general purpose computations in OpenGL, even though people used to do general purpose GPU computation using OpenGL, and this is, by the way, how GPGPU actually came to life, right? So GPGPU, have you guys heard about this concept? I feel like this is kind of an ancient term. It's kind of assumed that you can do that, right? So back in the days, GPU was a very much specialized hardware, and you have to say explicitly GPGPU. These days, I don't really hear that term very often. I didn't really hear it very often, but as far as I know, like the first time people literally just took OpenGL and shoved some data into a texture, passed that texture to a shader, and in parallel did some computation and managed to speed it up. And that's kind of like the first instance of GPGPU. And then the companies like looked at all of that shit and realized, holy fuck, we can monetize on that. And they started to have their own things like CUDA and Shuda. Everybody asks CUDA, but nobody asks if Shuda. Right, anyway. So yeah. Even though some people did general purpose computations in OpenGL, it still kind of requires a window. Coulda, shoulda, woulda, yeah, exactly. So, origin of Vulkan, what it takes to draw a triangle, instance and physical device selection, right? So you need to have some sort of a Vulkan instance, I suppose, just like maybe it's similar to OpenGL context, I suppose, maybe it's similar to that. A Vulkan application starts by setting up a Vulkan API through VK instance. Okay, and there is a link right away to specs, right? So, and they're not open. How can I have that shit locally? How is that even? So I suppose Kronos is like straight up like fucking banned in Russia, or is it blocking me, or is something? It is okay. So the website itself is fine. It's just the API. I'm not allowed to look into API, right? It's a classified information for the barbarian world. Anyway, so it's created by describing your application and any API extension you will be using. After creating the instance, you can query for Vulkan's supported hardware and select one more VK physical devices. That makes sense, right? So because maybe you have several devices that VK can operate on. Maybe you have several GPUs, right? In case of my laptop, I'm pretty sure I have 2 GPUs, right? Or maybe not, actually. It's a Ryzen AMD, so maybe it's all built in. Maybe I only have like a single GPU. But anyway, so there's a physical instance in here and whatever. So logical device and queue families, right? So there's not just a single queue, there are queue families. After selecting the right hardware device to use, you need to create VK device, right? So, okay, so there is a physical device, and within a physical device, you want to create a logical device. Okay. So where you describe more specifically which VK physical device feature you will be using, like multi-viewport rendering and 64-bit floats. Interesting. It's like, okay, VK physical device is like a literal, we can probably make an analogy with the servers, right? So with the servers, you have a physical server, which is like a shelf, right? And then within the physical server, you can install a virtual machine, and a single virtual machine instance is a VK device, and you can have several virtual machines within a single physical machine. Is that what it is, right? So you have a physical device, and within a physical device, you create a logical device, and you kind of limit its capabilities. It's like a virtual machine within the physical server. Is that what it is? It's AWS, right? It's AWS right in your computer, right? So that's why this API is so anal, because it's trying to be Amazon services instead of being just an API. So that explains everything, actually. So that's there you go. I haven't even started. I already understand why it's so anal. Docker-like, exactly. Where you describe more specifically which physical device features you will be using, like multi-viewport rendering, blah, blah, blah. You also need to specify which queue families you would like to use. Most operations performed with Vulkan, like drawing commands and memory operations, are asynchronously executed by submitting them to VK queue. Alright, so it's essentially if you want to do an operation on a VK device, right, so which then will be probably executed on a physical device, you have to submit that, you have to put that into a queue, and there's, so I suppose, different kinds of queues for different kinds of operation, and there's a whole family. Right, so there's a family. Okay, queues are allocated from queue families, where each queue family supports a specific set of operation in its queues. For example, there could be separate queue families for graphics, compute, memory transfer operation. The availability of the queue families could also be used as a distinguishing factor in physical device selection. Oh, so different. It's not like you can create any kind of queues. The devices must support a particular kind of queue. All right, so it's just basically what kind of operations do they support even. It is possible for devices with Vulkan support to not offer any graphics functionality. However, all graphics cards with Vulkan support today will generally support all queue operations that we are interested in. Okay, so that kind of makes sense, right? So far. Windows Surface and swap chains. Interesting. So I suppose this is specifically for graphics. Unless you're only interested in off-screen rendering, which is our case, you will need to create a window to present rendered images to. Windows can be created with a native platform API or libraries like GLFW. Oh, I know GLFW. Maybe we can use GLFW actually. And SDL. We'll be using that's perfect, GLW in this tutorial, but more about that in the next chapter. So we need two more components to actually render to a window. A Windows Surface, right, so there's a key HR. I suppose it's a Kronos something, but maybe it literally stands for Kronos, key HR. And swap chain. So know that KHR possible, they already explained that, which means that these objects are part of Vulkan extensions. Oh, so just having a graphical capabilities to display something on a screen in a graphical API is an extension. Nice. Swap chain, is this some sort of a blockchain? As far as, from what I remember, it's a abstraction over double buffering, right? So you can think of double buffering as a swap chain of two buffers. Professional graphics engineers in the chat, am I correct? Is swap chain is just a generalization of double buffering and buffering? Yeah, okay. So that's what swap chain is, right? In case of a double buffering, what is a double buffering? Essentially, you are rendering into a buffer that is not visible to the user, and then at the end of the rendering, you swap the buffers like instantaneously, and that's how you reduce sort of like flickering, right? So the frame appears to the user instantaneously, and that's why in all of the graphical libraries, graphical APIs, at the end of the iteration of the event loop, you have swap buffers or whatever. You probably saw that multiple times, and that's exactly what it's doing. It's swapping this kind of stuff. So Kamikaze says that it is, and buffering, which I suppose confirms my hypothesis that swap chains are just generalization of double buffering, because you can have triple buffering, right? So you can have multiple buffering and stuff like that. I can sort of understand three buffers. Honestly, I don't quite understand more than two buffering, is that useful when you parallelize? Like you are rendering two frames simultaneously, or what is going on? Why do you have more than two? I don't quite understand. It also somehow speeds up of rendering, but yes, yeah. Okay. So anyways, so this is what swap chains are, right? So you need a surface onto which, like Windows surface on which everything is displayed, and you need a swap chain. So we already figured out that it is an extension. The Vulkan API itself is completely platform agnostic, which is why we need to use the standardized WSI Windows System Interface extension to interact with the window manager, right? So the surface is a cross-platform abstraction over window to render it, and is generally instantiated by providing a reference to the native window handle, for example, HWD on Windows. Luckily, the GLW library has a built-in function to deal with the platform-specific details of this. All right. So the swap chain is a collection of render targets. Okay, there we go. So there's an explanation of what is swap chain. It's a collection of render targets. Its basic purpose is to ensure that the image that we're currently rendering to is different from the one that is currently on the screen. This is important to make sure that only complete images are shown, right? So it's basically a description of double buffering. Every time we want to draw a frame, we have to ask the swap chain to provide us with an image to render to. When we have finished drawing a frame, the image is returned to the swap chain for it to be presented to the screen at some point. The number of render targets and conditions for presenting finished images to the screen depends on the present mode. Common present modes are double buffering, vsync, and triple buffering. You will look into this in a swap chain creation chapter. Swap chain creation. This is a fucking whole chapter to create a swap chain. Fuck me. Swap chain creation chapter. Holy fuck, a whole fucking chapter. Alright, so some platforms allow you to render directly to a display without interacting with any window managers through the VKKHR display and VKKHR display swap chain extensions. These allow you to create a surface that represents the entire screen and could be used to implement your own window manager, for example. Alright, so kind of understand how it goes. Image views and frame buffers. All right. So as far as the frame buffers, there's just like buffers into which you render, which are not displayed, right? So maybe you're rendering into some sort of like a back buffer for post-processing and stuff like that. To draw an image, to an image acquired from the swap chain, we have to wrap it into VK image view and VK frame buffer. An image view references a specific part of an image to be used, and a frame buffer references the image views that are to be used for color, depth, and stencil targets. Because there could be many different images in the swap chain, you'll preemptively create an image view and frame buffer for each of them and select right one to draw at a time. Okay, so there's additional, so the boilerplate just to acquire a place into which you can put a fucking pixels. Alright, so to be fair, if you're not rendering to the screen, I suppose everything after step 2, right, is kind of irrelevant to you, isn't it? Well, I mean, yeah. So essentially what you want to do, you want to create an instance, you want to look at the physical device, you want to pick a physical device, create a logical device depending on the feature that you need, and create a queue, and you start submitting commands, and that's it. Right, so after that, it's just like, you don't need that even, probably. And that's exactly what I want to focus on today, right? So I don't want to create a triangle, so today is not a triangle creation stream. I just want to maybe create some program, create some sort of a payload, computational payload, run it on my GPU and get some results back. You need step 6. Okay, graphics pipeline. Okay, so it's interesting how they kind of skipped it. The graphic pipeline in Vulkan is set by creating VK pipeline object. It describes the configurable state of the graphics card, like the viewport size, the depth buffer operations, a programmable state using VK shared module objects. All right, so command pools, command buffers, and okay, so and command buffer, how? Wait, I thought you sent commands over the queue. As mentioned earlier, many of the operations Vulkan that we want to execute, like during operation, need to be submitted to a queue. Okay, so these operations first need to be recorded into command buffer before they can be submitted. These command buffers are allocated with command. Okay, so on top of having queues, you need to have a command buffer. All right, and then you need to have a main loop and so on and so forth. All right, so I think I kind of have an idea, an overview of what to expect from this journey. I kind of have an idea, so and it is called overview. Let's take a look at what it takes to even set up this kind of shit. Development environment. Okay, so Windows, we don't really care about Windows. Linux, I suppose we do care about Linux. These instructions will be aimed at Ubuntu, Fedora, and Arch Linux users, but you may be able to follow along by changing the package manager specific commands to the ones that are appropriate for you. You should have a compiler that supports C++. Why do you have to have C++? I thought it's a C API, right? So the most important components you'll need for development Vulkan application Linux are Vulkan loader, validation layers, and couple command utilities to test whether your machine is Vulkan capable. I'm not sure if this is really that important. I'm actually not quite sure. So, okay, so I want to start with GLFW. As mentioned before, Vulkan by itself is a platform agnostic API and it does not include tools for creating windows, blah, 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 to benefit okay. So GLM, as far as I know, GLM is a mathematical library, right? So it does not include library for linear algebra. I already have my stuff in here. So shader compiler. Okay, this is interesting. So we have just about all we need, except we'll want a program to compile shaders from the human readable GLSL to bytecode. Two popular shader compilers are Kronos Group GL Slang Validator and Google's GLS. Okay, so do I have that? GLSLC. Okay. Oh, I have that. Wait. Where did it come from, though? I already have that. That's actually pretty cool. So, do I have GLSLC? Oh, okay. So this is how you do that. It's not available though. So it was installed from somewhere else. Is there any way knowing? Okay, so essentially, GLSLC. Like, is there any way in XBPS, knowing the path to a file, know from which package it came from? apt file search, it's not apt. Okay, so let me take a look. apt file. So XBPS query. Okay, so XBPS query. So let me find right. Search for okay, so there's literally that operation. That's actually super cool. Okay, that's very cool. So who owns that? Shader C. All right. Okay. So I guess we learned a pretty cool technique. So let me take a look at what we have in here. So this is R. Wait, it's probably just shader C. Okay, here it is, and it's Apache maintainer orphan. Okay, so it's okay. It's kind of interesting that it's located in a package shader C, right? So shader C. So here it is. They actually mentioned that it's called shader C. It's just like in this blob of text, which is kind of difficult to parse, right? So it's a shader C, and maybe we could have taken a look at the repo in here. Let's take a look at the repo in here. We don't need this thing. So yeah, it's maintained a collection of tools, libraries, and tests for Vulkan shader compilation, obviously owned by Google. Google is trying to put its dick everywhere, so you all depend on it, obviously. Just like any big tech company. I wonder, like GLSLC, right? So what if we just try to feed some shit into it? Right, so Vulkan C. So let's go in here, and if I can I create like a main frag, right? So I'm not sure if there's a difference between frag and not frag. Let's actually call it GLSL. GLSL. What I want to do, I want to basically feed an empty file and see what's going to happen. Version desktop shader for Vulkan SPRV require version 4 or higher. Okay, so we're doing the empty file test, right? So empty file test. So it wants a version, and I probably have to provide the version. They already tell me what kind of version to provide. Yeah, so it wants 140. Let's actually say this is going to be 140. Okay, file encountered, but no shader stage specified ahead. What the fuck is a shader stage and why does it look like a flag? So can we take a look at the help in here? Maybe it's a dash. So shader stage. So it wants to have a shader stage. Treat subsequent input files as having stage. Valid stages are vertex, vert, fragment, frag, test control, test. Okay. So compute, geometry. Okay, this is actually super cool. So by the way, somebody said .comp in the chat. So does that mean that I can put these sort of stages into the extension and it will be automatically picked up by the compiler? Okay, they will. And it... Попьёдолило. Сука. What the fuck am I looking at? What is this? What the fuck has happened? Okay, double not supported with this profile. Where do you see double, my friend? I didn't provide any double. Empty, compilation terminated. Internal error, unable to parse built-ins. And it just shed out a bunch of built-ins, which are basic mathematical operations, none of which I actually called. And somewhere along the line, they forgot to add new lines in here. Who vibe coded this? Can anybody tell me, like, who fucking vibe coded this shit? They forgot new lines. What the fuck am I even looking at? If you're gonna shed out a bunch of stuff I don't care about, at least put lines in there. I suspect what happened in here is that they were outputting them in chunks, and in one of the chunks they literally forgot /n. Okay, so I don't know why it shed out all of that stuff. I literally don't care. So computers require ES profile with version 310 or non-ES profile with version 420. 420. Okay, so let's actually try 420. Why not 69? Computers require extension not requested. GL IRB GL. This is a Vulkan stream. Please, no filthy GL mentioning on this Christian Vulkan stream. Anyways, so can I take a look at, so what kind of extensions can we have? Extensione. So HSL functionality. So I suppose it supports also HLSL. So do we have GLSL? I don't see it actually. So, but anyway. Extensions by SPRV, they don't really tell me like what exactly to do. Compute shaders require extension request, extension not requested. Let's go back. Extensione. And that's the only thing. So functionality. Okay. So request. All right, GLSLC request extension. So scheduling specification extension. Extension specification. I just expect that it's going to be some sort of a flag, and obviously there is no flag in here. Okay, extension. Okay, So there's a shader stage and extension. Okay, so that's totally understandable. So there's a well, it's a shader stage. Let's specify the language of input shaders. Okay, so GLSL or not GLSL. So enable extension functionality from extensions GLSL specifications. I don't know how to enable a specific extension. They say you must request an extension. Okay, you motherfucker know what kind of extension I must request? Fucking request it for me. You know exactly what I want. You motherfucker want exactly what I want. Just do that then, or tell me how to do that. Okay, so... Alright, so we didn't pass the empty file test. We kind of got stuck on this kind of thing. Extension whatever. Why didn't it tell me that? It told me to use a version, pound version, but it never told me to use extension. Like, it's just like, what is this? Anyway, so what are we doing? Let's actually continue. So there's a GLSL and some other shit. Okay, so setting up markup file. Okay, so this is like a very simple thing. This is a very simple thing. And right off the bat, we're trying to create a window in GLFW, right? And is it even possible in GLFW to not create a window? Right, that's the real interesting question. I suppose if you're not going to be creating a window, maybe you don't even need any of these window initialization libraries. Maybe we don't even need any of that stuff. But okay, so let me try to see. So in here, GLW no API and everything. So there's a Vulkan. Let's actually try to create the window. Right, let's try to create it nonetheless. And then as we're starting to work with Vulkan API, maybe we'll see how we can get rid of the window. Okay, so let's actually start with that. So stop talking, start coding. Let's finally start coding. Let me maybe go and grab node.h. Node.h. Where is that? Here it is. I'm gonna do row 5 the power. So now I'm gonna just, this is not really what I wanted. I wanted to just do wget. Okay, so node.c. So nob.h define nob implementation, right? So let's just see what we can do. Int argc char argv and nob go rebuild yourself. Argc argv. All right. So so we need to do append, and we're gonna start with just clang. Do a little bit of a clanging. Extra and o. Let's call it main. Right, so this is going to be just main. Right, so this is going to be just main.c, and cmd run cmd, like so. All right, so nob.c. And let's just run this entire stuff. Cool. And in here, I suppose main just doesn't do anything particularly useful, so might as well just print something in here. Hello world. Hello world. Okay, so this is a hello world. So we're gonna start with GLFW, like creating a window and stuff like that. So yeah, where is the example? Am I opening what? Did I lose it already? The development environment. Oh, here it is. Like I remember there was an example and stuff like that. Include Vulkan, by the way. This is interesting. So in user include GLFW3. Right. So and we can take a look at the GLW include Vulkan. What does it do? Oh, it literally just includes Vulkan. Do I even have it? I do have it. Look at that. Vulkan.h. There you go. I have all of these interesting things. I can probably even query some of the stuff. So can I query things like VKQ, right? So, oh my God, holy fuck. Is that a function though? Is that a function? Okay, it is a function. Is it purely C++ shit? Wait a second, I can't... Is Vulkan purely... No. What the fuck? Excuse me, why there's a... Why is this C++ shit? So, Vulkan is not usable without C++? Is that what you're telling me? What the fuck is that? Excuse me? Looks like there's some non-C++ thing. Okay, so maybe there's just a combination of C and C++. Alright, maybe it is usable. Is that a structure? Well, it kind of is a structure, but is it not? So I suppose maybe I just want to know what is VK, right? So what is VKQ? I mean, so far it tells me that this is some sort of a structure, right? Is it a class? Right, no, it's not a class. Is it a struct? No. So bizarre, but okay, we'll get to that a little bit later. But what's important is that now at least I have like headers against which I can maybe grab something. So there's even links to the documentation, but we already established that they are not... Chat. Roskomnadzor missed this website. They banned Kronos API, but they missed docvulkan.org. We found a loophole. We found a loophole so we can actually learn some new things. Holy shit. I feel like a hacker. I found a loophole. So VK is a fake pointer. Is that type def? I forgot how. I keep forgetting how type def actually works. In the type def, first comes the one that you alias or what? Oh, okay. So comes the first comes the value that you're trying to alias, right? So it's kind of. All right. So that means maybe VKQ. And no, is it void? Nah, maybe there is no even such thing. But anyway, whatever, chat, whatever. Calm down, chat, calm down. All right, so we're gonna be actually doing the thing. So main.c. Right, we are defining GLFW. GLFW include Vulkan, блять, сука. And here we have GLFW3.h. Right, so let's actually see if it's going to compile. Okay, it compiled, but this is because we never try to call anything. What if I try to initialize this motherfucker? So I'm straight up initializing it. Look at that. Boom, it doesn't fucking compile. All right, node.c. What we need to do in here is probably lglfw3. Okay, and is it just GLFW? Yeah, boy. So LDD, what in terms of LDD? We do depend on libglfw so. If I do main, nothing fucking happened because we didn't fucking do anything, obviously. So we have to do GL window hint client API, no API. So we explicitly included Vulkan, but then we requested please no API. Is that what it means though? I'm not quite sure what the fuck is going on in here, but in GLFW, let's actually try to grab for no API. What do we have in here? And it doesn't even explain what the fuck. Yeah, okay, there we go. So there's a no API or OpenGL API. But is there something like a Vulkan API? There's no Vulkan API because I suppose no API is Vulkan API. No API means no OpenGL. Why didn't you call it no OpenGL? No robustness, obviously. That's what you want to have. Man, so, you know, sometimes I feel like my software is too robust. You know, it's too fucking robust. It's a age of AI. It's an age of slop. You know, I'm gonna enable no robustness. I'm gonna get in with the times. no so let's actually go back. So main.c. What I do, gl window hint client API, and let's just like create this entire shit. Okay, can I just do not really main? I want to do nob. Maybe in lenob.c I can do the following thing: cmd append main. So here is the main, and we're gonna run this shit right after that. There we go. So it says hello world. Nothing's happening so far. We're just creating shit. The next thing we want to do, we want to create a window, right? So 800 by 600 Vulkan window with a bunch of null pointers, disgusting C++ null pointers, disgusting. Anyway, so so as far as now, null PTR is also going to be keyword in C23 or something, right? So I kind of remember they wanted to introduce that there. Create window, show me how do you create a window. So you can specify a monitor and you can share or something, but I'm not quite sure what the fuck is share. All right, so let's fucking go. Let's fucking create this shit. My monitor has died. All right, so in here I'm gonna probably specify just the nulls, right? And yeah, we can maybe print the pointer to the window. Why not? So this is the window. There we go. So here's the window. So extension. Okay, this one is interesting. Extension count. VK enumerate instance extension properties. Let's copy paste this scheisse. Let's go into Vulkan and grab this mother flipper. So can we quickly find the location? Okay, so I feel like that's where it is. Here it is. VK instance extension properties, and there is no link to doc VK stuff, right? There's no link to that, but I feel like I have an interesting feeling, chat, that if I place this thing in here, no result found for VK enumeration instance extension properties on a Vulkan documentation website, docs.vulkan.org. In this component, okay. Oh, it instantly found it. Well, I mean, you could have actually catch that, right? So doesn't work. Ref pages work. Guides don't work. Interesting. Yeah, so only this specific page work, but it's impossible to, yeah. Okay, anyway, whatever. So maybe we can do, oh my god. Okay, so it's created by these kind of people. Okay, fine. I see how it is. So there's a VK result. I'm not really sure what the VK result. Maybe it's some sort of a type def. So layer name. I have no idea what the fuck is a layer. And yeah, so there's a property count. It returns a property, and also you can get a bunch of properties. So I suppose you can get a list of them even. Right, but if you specify null, it will probably return nothing. Okay, that's pretty cool. So let's go ahead and just do that. Okay, good. It has to be null. All right. Can we? So there's also kind of like this result. Can I just do result? So this has to be uint32 property count, right? Get out of my property count, and in here I suppose it's gonna be null. All right, so what I want to take a look at, chat, is all these different things that we got. So I'm gonna assume that VK result is an integer. I think it kind of makes sense, but it could be structure, by the way, you never know. And in here, so this is a property count. I'm gonna put a U in here. So this is a property count. Property count. There we go. Let's try to run the whole thing. And okay, so this is actually kind of great. So it compiled, but it didn't link. So that means it found all the necessary headers and stuff like that. So I suppose now what we have to do, yo. We have to link with Vulkan. I wonder if it's as easy as that. It is. Property count 24. Now, here is an interesting question, chat. What if I say, well, fuck GLFW, fuck you. Can I just run that without any GLFW? I can't compile it, obviously, right? So, what are you saying? It's probably because I have to do this int, right? So it can't do that. And yeah, so, but we can do the following thing, include Vulkan. What if we directly include the Vulkan headers ourselves, entirely ourselves, without any GLFW? Caught you. You thought you could trick me? You thought you could trick me into needing GLFW library? I see you through, motherfuckers. I see you all through. You don't need them. I got all of the extensions without your stinky fucking window. This is exactly what I'm talking about. And this is, by the way, I want you to try GLFW first because I knew that at some point we're going to start doing VK API, and then I want you to try, can I do this VK API without GLFW? So that's an interesting thing. But here's the fun part. This VK enumerate instance extension properties, it accepts a pointer, which probably means that we can get a list of these extensions, right? So can we get the list of these extensions? And by the way, this thing is correct. So it is in fact a number. So do I have all of the warnings enabled? Yeah, so all of the warnings are enabled, which means that if, for example, if I put LD in here, it would warn me that, okay. So it explicitly has to be just an integer, just a regular integer. So how can we do that? I feel like it promotes one of these patterns. Chat, please don't tell me that it's a sprintf situation or a sendprintf situation. Is that a sendprintf situation? It's, oh, for fuck's sake, On the other hand, how else do you do that, right? So it's just like, so essentially, a sendprintf situation is that if you want to get the list of the extensions, you have to call this motherfucker twice. First time, you acquire the amount of extension, right? And then you allocate enough memory to accommodate all the list of the extensions, and you call it again. You call it, I see. Thank you very much. Very cool. Anyway, Vulkan core. So, and we have VK extension, which I suppose is the structure. And okay, so it is in fact the structure, and you have extension name. Okay, so VK max extension name size, right, and a spec version. So which also raises the question, how big is it? Show me your size. Okay, so I suppose it's 256. Pascal was right all along. You don't need strings bigger than 256. There you go. So max extension name and stuff like that. Yeah, it's pretty cool. It's pretty cool. It's pretty cool. So let's go back to this thing. Where was it? Here it is. So what we want to do is basically just allocate all of that stuff, right? So this is a properties and properties. And essentially, we're going to malloc this entire stuff. I'm going to take size of these properties dereferenced multiplied by property count. And then go. So then I'm probably don't need to res or anything. Maybe I can even do something like this. So we pre-allocated this entire stuff, and then we call it again. And I wonder, can we just put a null in here and only provide the properties, because we already know the count. So I suspect they're not changing, right? So it's kind of interesting. Do I have to provide it, or yeah? So I think no, I don't have to provide it. Okay, so let's actually iterate through all of this stuff, and this is going to be I0, I less than property count plus I. And what we want to do in here, chat. What we want to do in here, chat. I wonder if they're null terminated, by the way. Properties. What was the? I think it was just something like p name. I already forgot, chat. I already forgot. Fuck me. What was that? Should have saved it. Come on, man. Okay, so it's an extension name. Okay, that is very, very cool. I'm gonna put it in here somewhere. So this is extension name. All right, and what do I do? Extension name. I'm gonna. Well, I mean, if it's not null terminated, it should have at least the this length somewhere. Since it doesn't have a length, it is probably null terminated. So let's say spec, and this particular spec is u, right? So it's going to be properties spec version. All right, what else do we have in here? So let's go ahead and try to compile this scheisse, and res doesn't know about malloc. Let's do stdlib. Okay, so this one is unused, which is, are you serious? Okay, so it guess where it segfaulted. Guess where it's segfaulted. I swear to God. Okay, so you can't omit a pointer to property count, but yet you can omit some other things. Fascinating. All right, there we go. So here is the VK device group creation. So display external fence capabilities. So memory capabilities, semaphore capabilities. Get display properties too. Get display properties was so good they created get display properties too. Get physical device properties too. Get surface capabilities too. Okay, so surface protected capabilities, Wayland surface. Okay, so XCB XLeap surface, acquire DRM, debug utils. So headless surface, surface maintenance one, swap chain color space, portability enumeration. That's pretty cool. So honestly, this is kind of self-explorable. I kind of like how Vulkan so far is in fact self-explorable, right? So it feels more type safe than OpenGL. One of the main problems of OpenGL is that you look at the signatures of OpenGL and you don't know how functions connect to enumerations and stuff like that. There's just like, it's too opaque. Right, it's explicit, and that's one cool property of Vulkan, right? It is very much explicit. You have a signature of a function, it refers to a specific struct, you can find that struct, you can explore it, it refers to something else, and so on and so forth. You can kind of like explore things, at least, to some extent. It is verbose, right? So it is verbose, but at least it's connected together. Right, so, and I suppose, at least this is what I heard. Vulkan doesn't try to maintain hidden state, unlike OpenGL, right? One of the. Why do we have 1,150? What the? What? You guys into this shit, right? So, what the fuck? All right, I don't complain. Okay, this is just like I didn't expect that. It's your view bots. All right, that's fine. It's fine. Anyways, so what I was saying. Yeah, one of the thing about OpenGL is that it's like a hidden state and stuff like that, and in here it doesn't really have a hidden state, right? So you explicitly maintain that state. Paid viewers, yeah. Viewbots. All right, so apparently it is a hot topic. All right, cool. Nice to know. I didn't know that. Okay, so what else do we have? What else do we have? I suppose none of that matters anymore, right? None of that matters. Keep in mind, you're not required to understand all this code is doing yet. We're just setting up some API calls. Okay, but I already understand like roughly what it's doing. So, all right. I think our development environment is already set up. We literally managed to create a program that created. No, it didn't really create VK instance yet, but it already queried some of the properties of Vulkan in here, right? Thank you so much for the sub. By the way, I actually kind of missed a bunch of subs, let me acknowledge them. So, Red Santor, thank you so much for the Prime. Tamaguchi indeed. Kathy64_T, thank you so much for the Prime with the message Vulkan. Bajuding indeed. Zahatikov, thank you so much for tier 1 with the message Ayo. Thank you so much, Ventus Work. Thank you. So you guys are sending my brain rot back at me in the subs. I see what you're doing. All right, drawing a triangle. So we don't plan to draw a triangle per se, but I think it's still gonna be. Oh my god, it's still gonna be useful. It's still gonna be useful to just maybe create VK instance. All right, so hello triangle. This has like a strong 2010 vibes. Right, so from the times of like QT and shit. So we first include the Vulkan header from Lunar G SDK. What the fuck is Lunar G? Is this like a Baba G? But it's a Lunar G. Is an American software company specializing in device driver development for video cards. Ah, okay. So interesting, and it's like, how is this related to Kronos and Vulkan? And it's like, it's just there's so many stakeholders on this API. It's kind of insane, right? So there's just so many companies are invested in this shit, which is maybe good, right? I don't know. We first include the Vulkan header from the, like, I don't want to do any lunar. Oh, it's basically it's a vendor of the Vulkan headers or whatnot, right? In our case, we're installing it from void repositories. So, by the way, this text looks like whatever Clanker generates when you asked it to explain a piece of code, right? Have you noticed that when you ask a clunker to explain a piece of code, what effectively it's doing, it translates the code from programming language to directly just English, right? Without really compressing and, it just directly describes what it is, which is, arguably worse, right? So because it's more like it's the volume is bigger. So resource management. Just like each chunk of memory allocated with malloc requires a call to free, every Vulkan object that we create needs to be explicitly destroyed when we no longer need it. Are you sure about that? Are you sure about that? What is this? C++ery? What is this C++ery? Isn't operating system going to clean up all of the resources for us? Or are you telling me that if I don't destroy some of these objects, they're gonna outlive my program and gonna consume all of the VRAM or whatnot? Is that what you're saying? Excuse me? So hopefully it will. Okay. OS will figure that. Like, I expect operating system to do that for me, right? Anyway, in C++, it is possible to perform automatic resource management using array AI or smart pointers. I know about array AI and smart pointers. All right, so however, I've chosen to be explicit about allocation and the allocation of Vulkan object in this tutorial. After all, Vulkan's niche is to be explicit about every operation to avoid mistakes. So it's good to be explicit about lifetime of object to learn how the API works. Remember, explicit is better than implicit. Guido van Rossum said that a long time ago and created Python. And that's why everybody likes Python, by the way. So after following this tutorial, you could implement automatic resource management by writing C++ classes that acquire Vulkan objects in their constructor and release them in their destructor, or by providing custom deleter to... Oh, wait, unique PTR and shared PTR have a custom deleter? I thought they are only operating... yeah, I thought they just called destructor or whatever. Okay, nice to know. I guess I learned something. So depending on your ownership requirements, is the recommended model for larger Vulkan programs, but for learning purposes, it's always good to know what's going on behind the scene. So Vulkan objects are either created directly with functions like vk-create, okay, xxx, or allowed through another object with functions like vk-allocate. After making sure that an object is no longer used anymore, you need to destroy it with the counterparts vk-destroy and vk-free. The parameters for these functions generally vary for different types of objects, but there is one parameter that they all share: p-allocate. Allocate is so good. Everyone calm down. It was just pouring water. Don't worry about it. Just poured some water. Cheers, by the way. P-allocator, I see. Fascinating. This is an optional parameter that allows you to specify callbacks. For a custom memory allocator. We will ignore this parameter in the tutorials and always pass null PT. This is cool. Okay, so, all right. Integrating GLFW. We don't really use GLFW, so I guess we don't care. Works perfectly fine without creating a window if you want to use it for off-screen rendering, but it's a lot more explicit to actually show something. First, replace include vulkan.h with line. Okay, so this is not interesting. You're giving me specific instructions. We already went through all of that ourselves, right? We don't really need you for these kind of things. Okay, so yeah, this is just GL, like we are not interested in that. We're interested in instantiating VK. Okay, so we need to create VK instance. Let's take a look at it. Like, what the fuck is a VK instance? So let's take a look at that. I suspect that it is a structure, so it's probably defined something like this. There you go. Motherfucker. So is it more like a struct? No. Fascinating. So what is it then? Is it a class? Okay, so not quite sure how to find this entire thing, but one thing I suppose we have to do, we have to create VK instance. All right, so it compiles. That means it actually found all that stuff. So result is not particularly used. So can we find VK result where VK result is defined? I'm also not sure like how to find that. VK result. Okay, found it. It's a struct. It's an array. Okay. All right, so, and there's a lot of them. Oh, and by the way, the cool thing is that I can probably find who accepts VK result. So there's a functions for VK instance or whatever. Maybe there's some functions that literally just accept VK result. So maybe I can render them into a string or whatnot. Nah, there's no such function, but I mean, it was a kind of nice try. But anyway, so what I want you to do is maybe just put some stubs in here. Assert res not equal to VK success, right? So just like assert this kind of stuff. So we're asserting that, and also we're asserting that properties are not null, right? So instead of like a error handling, we're going to be asserting things. It's just like easier to do that. So this is extensions. We don't really need that because we already have all of the necessary information in here. So GLFW is not really needed. And I feel like, by the way, I never tried to compile this example without linking with GLFW. Right, what if I don't do that? Right, so what's gonna happen? Knob. So assert, okay, so that's understandable. We just need a couple of things in here. Assert, and Okay, so I'm a little bit of an idiot. That's understandable. So it has to be equal to the success. All right, and everything works nice so far. Okay, so this is VK instance. So to create a VK instance, we have to first fill out VK application. You have to fill out an application to get an instance. This is the most bureaucratic API. Like an application, right? So you have to apply to receive the fucking instance. Okay. Modern API, VK Office, yeah, exactly. So now to create an instance, we'll first have to fill in a struct with some information about our application. This data is technically optional, but it may provide some useful information to the driver in order to optimize out specific application. Wait! I remember that. I remember on Twitter seeing somebody rant. I don't remember who it was. I'm sorry if I don't remember. But somebody ranted on Twitter like, what the fuck is that? Are drivers using this information to put hacks for specific games? And the answer is yes. So the driver knows it's basically user agent all over again. This is literally user agent situation, like in browsers. So so stupid. I mean, there's some, I remember on Twitter there were some arguments for that, which is essentially the drivers were doing that anyway because they were observing how exactly the API is used, and they were detecting game by the API usage and were providing hacks to improve the performance of specific games. So that was the main argument, that drivers were already doing that, and since they're already doing that, why not just explicitly provide that information anyway? So that's the argument. I don't know how much it is true because I'm not a graphics engineer, but this is something that I heard. But anyway, so you can provide this information. And yeah, let's fucking go. Let's remove all of that C++ery, but maybe one thing we can do, we can just like fill out with 0. But another thing I would like to take a look at is probably the definition of the struct. So one cool thing when you're learning things is just like to take a look at the definition of each individual thing you're using in here, like explicitly. So VK is struct type. So this is a sort of like a tagged union, but not really tagged union, but yeah. Excuse me? Is this a motherfucking linked list? Didn't expect that. Linked list jump scare all of a sudden, like, alright. So I suppose you can have... Why? And it's... What's interesting is that it's fucking void. It's opaque, right? So what if I provide whatever in there? Should have been B-tree. Yeah. Should have been B-tree. Alright. So what is a VK struct type? VK struct type. Honestly, we might as well actually just fill out all of that shit ourselves, right? So let's not do any of that stuff, right? Let's not do any of that stuff. Let's fill everything out ourselves so we understand it better. I think it is much better for understanding if you do it like that. So first of all, what is VK structure type? So Vulkan, grep, and oh, okay, so there's a lot of things. Maybe the definition of it looks... Okay, so it is in... Oh my god! Structure type physical device maintenance 6 feature KHR. Oh, holy fuck. Get some subs. Thank you so much. So Nitrix Dev, thank you. Oh, okay, so I missed... so Windows Works, thank you so much. Vivoivario, thank you so much for Twitch Prime. I was official, thank you so much for the Prime with the message. Allocate my P, please. Thank you so much. Nitrix Dev, thank you so much for tier 1 with the message recreational watching indeed. And Cyan Sec, thank you so much for tier 1 subscription. Anyways, so what are we doing? So application type, application info. Motherfucker. Okay. So it's literally tagged union. It is literally tagged union. So I suppose there is several structures where you have this field. There must be several structures, and we can probably find them all. Right. So that's what it is. It's a struct. There. And this is what I was seeing. Right. Okay. P next. Okay. And all of them, look at that. All of them have this P next. Right. Maybe you can actually chain several of these things together. But why? But anyway, and the name is a little bit worrying, chat. The name is a little bit worrying. You know why? Because it's very abstract. VK structure type. So you're telling me there is an enumeration for each individual structure in Vulkan, at least for those where you have S type. So all of these structures are polymorph. I can't believe that. All of them. Most Vulkan info structures used for the create X function and a lot of other Vulkan structures need S type and P next set. This is used for extensions and some extensions. Did you copy paste that from the documentation? You probably did, but thank you so much. Yeah. So the thing is, the reason why I don't read documentation is because I like to discover these things myself. You know what I'm saying? I really like to discover these kind of things myself because it kind of makes it easier for you to understand it and remember things, right? So because when you read documentation, the information is handed to you, but when you discover that information, you internalize it. You kind of make it yours. You know what I'm saying? That's why I like to kind of discover things rather than just like... Sometimes it's not possible. Sometimes, obviously, some information is kind of difficult to acquire yourself. But yeah, it's kind of hard to discover void star. Yeah. Anyway, so I suppose here we have to explicitly say VK structure, application, whatever. I wonder if they actually wrote all of that themselves manually. They probably didn't, right? So they probably generated it from higher level description or whatnot. App info. I'm pretty sure they did. So in case of the next, let's actually set it to null, right? So it's gonna be null because it's already 0 initialized. Okay, so we have application name. So what's gonna be the application? Vulkan, I don't fucking know. Your mom, that's the application name. So application version, this one is interesting, it's gonna be app info is gonna be 69420. Might as well actually do that in hex. Engine name. Got. So what's gonna be our engine? V8, I suppose. So app info is gonna be 37. API version. I'm not really sure about. Oh, fuck. You have to do that in a very specific way. Make VK make version. All right. So let me see how you use this thing. Let me see how you use this thing. Okay, so major and how is it combined? Ooh. So you have 12 bytes per version. Not even 12, right? So, yeah, because it's not exactly. It's kind of interesting. Oh, right. I mean, should be enough for me. Let's try to do that. Could have made it a structure, like a very small structure, but I mean... Anyway, 69 for 20, this, and this one is gonna be something like this, 13, 37. That's basically our version. API version, I suppose this one we have to explicitly say like what kind of Vulkan API version we're using, right? So that's what we have to do. App info. And here is an interesting thing. What functions accept this type? Can we find them, chat? We can't find them. Maybe if we directly just search for these things. So do we have any? I actually don't see any function that accepts this stuff. Maybe some of the functions, don't tell me that some of the functions accept application info as a void star. And that's why you have discriminator inside of the structure, because they will figure it out anyway. So the thing that I was prizing Vulkan for, being explicit, I feel like it just vanished, if that's what they do. They do sometimes. Fuck. Anyways, so as mentioned before, many structs in Vulkan require you to explain. Oh, this is where. Thank you, Kamikaze, for copy-pasting this paragraph into the chat. Anyway, I was just trying to figure out things. So a lot of information. Oh, it's actually passed into VK instance creating 4. Fascinating. So that means there should be a field in here. That field should be mentioned, and here it is. So there is not a single function that accepts VK application info, but there is a VK instance create info, and this motherfucker is also sort of like tagged. It is also tagged, so you can specify the flags, and there's a PP enabled. PP enabled. Okay, so we create that P application info, app info, and you don't really have to even specify all of them. Only that, yeah. So you're just wrapping application info. That's what you're doing. That's what you're doing in here. Okay. So let's go ahead and just do that. Just do that. So VK instance create info. Create info. 0 initialize it, obviously. And let's create as type VK struct structure type instance. Is it create or is it instance create info? Auto-completion create info, and this name P application info. I have to provide the pointer to that app info. There we go. So we're filling out this thing, then we're wrapping it into a structure create info, and I suppose VK instance create info is sort of like a command, right? And then you'll have to send that command to Vulkan. Very cool. So does it compile? It doesn't. Well, I mean, so we still not using VK instance, but overall, all of that stuff compiled. And here we can apply the same sort of idea. What accepts this stuff? Who accepts this stuff? Nobody. Okay, let's take a look at all of the places where this thing is used. And there's some functions in here. So there is create instance, where you have to pass create instance info. And this one is like a pointer to this function. So I'm not quite sure what's up with that. So there's probably global variable. Yeah. Okay. So there's this variable VK create instance. So that's probably the function that we'll have to call. Yeah. I can see that. VK create instance. Yeah. VK create instance info. VK allocation callback. We probably have to set it to null. And VK instance is probably where it's going to be outputted. So I'm not gonna read tutorial any further. I'm gonna try to make a wild guess, literally. I'm gonna try to make a wild guess. So here I'm gonna actually return this thing. Then I'm gonna provide create info, pointed to the create info. And I suspect allocation callbacks is literally for custom allocation, and we can set them to null. Right, so but we can just try to find them and see. Right, so Well, I mean, it's a structure. Well, why am I doing it like that? It's not a function, it's a structure. And here, what we have is a state of a custom allocator, allocation function to allocate reallocation. So it's a malloc, realloc, free. Internal allocation is an allocation notification and internal free notification. Some additional things probably specific to Vulkan, right? So, but this is like the usual malloc, realloc, and free, right? The custom ones. And I feel like I can just probably set all of that stuff to null. An instance, well, let's provide a pointer to the instance. And here's the thing. So in return, we want to check that it was successful, right? So we're going to check that it is successful. And I'm not quite sure. So do we have, like, can we inspect VK instance? If there's anything interesting in it, I wonder, or is it opaque? Right, so I'm trying to run it and see if it's going to be successful. So it's a res, it was called the res, I suppose. Okay, it was successful. We successfully created instance, and I'm not even sure like what it is. You can't, it is opaque, I see. Is there at least definition of VK instance somewhere? Because I'm kind of curious. Is it literally type def void or whatever? Let me see. Or is it maybe a struct? So VK instance. Yeah, so I can't see that. I think I already tried to do that. Okay. Well, I mean, okay. Can I do type def and then just something like that? I literally can't find, like, where is it defined? Wait a second. Could it be that it's literally a macro? No, it's not a macro. Where is it defined? Okay, VK define handle. Okay, VK define handle. VK instance. Okay, okay, so here it is. So, and what is VK defined? What an assholes! What an assholes! Holy shit! I was specifically gripping for type def, and they had assholes. That's the only word I can have for describing that. Assholes. Anyways, so got some stuff. Very cool. So how many things accept VK instance? All right. So is it difficult to find them? So what's their usual style for that? I suppose maybe I have to put backslash. Yeah, there we go. Yeah, VK. Yeah. So can I put it like that? VK instance. Oh, it actually. Oh yeah, it's that allocation was with. I see. It's fine. So I probably need to do something like that. So here are different functions that do different things with the instances, right? So for example, create direct frame buffer surface, right, with an extension. So it accepts some structures and allocate. Look at that. A lot of these functions do accept custom allocator, and that was already mentioned in the tutorial. In the tutorial, they actually said that they accept p allocator everywhere, and here it is. How many places do they accept it in? Right, I suppose it has to be more like this, or more like this. Yeah, there we go. So that's a lot of different signatures. Look at that. Right, but not that many, honestly. Only 130. Right, so for Vulkan API, I don't think it's that many. I don't think it is that many. All right, so there is a little bit of a work with GLFW, right? And we have to acquire instance extent. Oh my god, no, please, chat, please don't tell me that we have OpenGL function loader situation, because we have all of these type defs, and then there's global variables type. Do I need a separate library for fucking loading the functions? Oh. It's literally like, why did they made all of the horrible design decisions of OpenGL? Like, I mean, on the other hand, like they have to support like a lot of additional extensions and stuff like that. You could do it by hands. I could, and this is literally what I do with OpenGL usually. Volk. Do it by hand for Win32. I do it by hand, okay. Best design the committee could come up with, yeah. This sounds like a name of a compiler, right, honestly. So somebody need to... Oh my god, this is a banger name for a language. Language Zaya, right? And the compiler for it is Zayas. Giving it away for free. Banger name. Absolute fucking banger name. Zaya language with the compiler Zayas. You're welcome. If you're gonna use that, at least credit me, I suppose, maybe. I don't know. So what we're doing in here? So we're doing that, and we create instance. We figured that out ourselves, entirely ourselves. How about that? So, and yeah, so throw in exceptions. Okay. Throw in exceptions. Encount VK error incompatible driver. So if using macOS, we're not using macOS. Check in for extension support. If you look at the VK create instance documentation, you will see that one of the possible error codes is error extension not present. We could simplify specifying the extensions we require and terminate if that error code comes back. That makes sense for essential extensions like the Windows system interface, but what if we want to check for optional functionality? To retrieve a list of supported extensions before creating an instance, there is the VK enumerate instance extension properties function, which we already called. It takes a pointer to a variable that stores the number of extensions on an array of VK extension properties. We know that to store the default, blah, blah, blah. And we already figured that out ourselves. Entirely ourselves. So epic fucking around versus reading documentation. We anticipated that shit just by fucking around. Isn't that fucking cool? Isn't that fucking cool? So cleaning up, destroy instance, and okay, so let's go. Okay, why does it accept? I suppose this is a p allocator, right? Because if you're destroying everything, you also need to call to the p allocator to deallocate the p. All right, so let me see. Let me see. P has been allocated. You thought P was stored in the bowls. It is actually stored in the P allocator. All right, so let's try to do that. We can use arenas probably, even for all that shit. It doesn't return anything, by the way. Look at that. It never fails. Interesting. And here is going to be null. And let's fucking go. Meine Freunde, fucking go. So, nope. All right. Everything seems to be Gucci. Everything seems to be Tamaguchi. We created an instance after 1.5 of an hour. We managed to create an instance. Isn't that a poggers? Validation. Oh my god. Validation layers. What the fuck is that? The Vulkan API is designed around the idea of minimal driver overhead, and one of the manifestation of that goal, so it's a very scary statement, one of the manifestation of that goal is that there is a very limited error checking in the API by default. Even mistakes as simple as setting enumerations to incorrect values and passing null pointers to required parameters are generally not explicitly handled and will simply result in crash or undefined behavior. I see. Because Vulkan requires you to be very explicit about everything you're doing, it's easy to make many small mistakes, like using a new GPU feature and forgetting to request it at logical device creation time. However, that doesn't mean that these checks can't be added to the API. Vulkan introduces an elegant system for this known as validation systems. Elegant system. Chat, who works professionally with VK? Is that an elegant system? Is that claim is true? Is it as elegant as they're saying it is? I think yes. Okay, so I believe you. Kinda. I see. Validation layers are optional components that hook into Vulkan function calls to apply additional operations. Common operations in the validation layers are checking the values of parameters against the specified to detect misuse, tracking creation and destruction of objects to find resource leaks, checking thread safety by tracking the threads that calls originate from, logging every call and its parameters to the standard output, tracing Vulkan calls for profiling and replaying. That's very interesting. So, okay, so there is this, God, this formatting is ass, right? So because I don't understand where the function starts, right? So this is argument, and this is where the body starts. All right, so create instance. So here's an example of what the implementation of a function in diagnostic validation layer could look like. So creating for pallocator instance, if okay, so if and for equal log null return and then real. Okay, I guess these validation layers can be freely stacked to include all the debugging information. So it's just like it provides wrappers around the functions or whatever, right? So that's what it is. It's just a wrappers around. So in this section, we'll see how to enable the standard diagnostic layers. Okay, so do we care about this shit? It's just like it's just enabling different diagnostic stuff. Do we wanna deal with that? Yes, we are. Okay. So because if I fuck up, it's gonna be impossible to debug, right? All right. So we need to enable some validation layers. I'm already streaming for almost 2 hours, right? So I think the time has come for me to make a small break, make a cup of tea, and after the small break, we're gonna continue. Like, and maybe we're gonna enable the validation layers and stuff like that, right? So, so VK config can inject them at runtime. Nope, not getting baited by that rabbit hole. Nope. Haha, I see what you try to do. I'm not getting baited. I have too much experience with streaming. So, music pilot Red Sun and shuffle OGG. All right. Okay. So let's make this break and Yo! I'm back, by the way. So we're steeping T. I really need a break because I don't know. It's a very dense API. It's a very dense API. So, do we have any professional VK developers in the chat? Please tell me, how close are we to running some computational payload on the GPU? Are we close enough, or is that like a miles ahead? So 2%? Well, I mean, 20%. Okay, I believe Deso used more. I don't know, Sifon, how much you worked with VK, but 20%. Pretty damn far. 4 days minimum. I see. Likely compute is a lot less work than GFX. Well, hopefully. Right, so I want to just do a very simple thing, some sort of computational thing. Maybe upload the shader, upload some data, modify that data and get it back. And yeah, I don't know how much time it will take. But luckily, I'm not even sure if we need any swap chains for that. Matrix multiplication, maybe, I don't know, just pass a matrix and multiply each element by some scalar or something, like, you know, something to confirm that we can do general purpose computations on the GPU. Compute pipelines are relatively easy. Okay. I'm a bit sad about web GPU being more explicit, more verbose, and almost impossible to use. Interesting. You still need memory buffer, pipeline layout, and command pool and command buffer. Okay, so we can create all of these things. Compute pipeline creation is much easier than the graphics one. Yeah, I already noticed that. Like yeah. So just like you at least don't need a swap chain. I have an example already in case you get burned. I have a whole internet in clunkers, but thank you so much. You can indeed have a device that is compute only and does not support. Yeah, we didn't even get a physical device. We didn't get to the point of a physical device yet. Compute pipelines. Yeah. You don't need a swap chain for graphics pipeline either if you write the result to a buffer. I guess. Yes. Physical device can be pretty quick. Well, yeah, I can understand that. Probably there is some sort of a function that get me the list of physical devices. Okay, next function. Pick the physical device. Then create a logical device out of physical device with this list of features. Okay, so it's probably like that, right? So given the description and how the API goes, and to get the list of all of the physical devices, it's probably similar to getting extensions, right? So first you query the amount of physical devices. Okay, I allocate an array to accommodate the list of physical devices. Then I acquire the list of physical devices, I iterate it, look at their names. They probably have a p-name field with the width of 256 because that's the maximum name possible in the Vulkan API. I look at them, I find the one with the vendor that I want, I pick it, right, and then I pass it around. It's something like that. It's kind of predictable. Like you can see what's gonna go next. Right. It's easy if physical device count equal to 1, yeah. Then just continue with it. But I want to get a list of all the physical devices that I have in here. Alright, so I wonder what kind of applications people use Vulkan for. AI? Llama CPP uses Vulkan, for example, for inference. It's one of the backends for the inference. Alright, so it has several backends. One of them is Vulkan. So AI, crypto. The usual stuff you would use GPU for, right? If I understand correctly. Yeah, this is like everything GPU, right? If you want to utilize GPU, you can use Vulkan for that. Blender moved to Vulkan 2 recently. Interesting. Everybody's ditching OpenGL lately. Even Jonathan Blow, bully in OpenGL. I suppose he was always bullying OpenGL. But, all my homies hate OpenGL, I guess. John Blow also talked about, yes, he talked about it. He constantly bullies OpenGL. Even though Simp, the graphical library that comes with Jai, still uses OpenGL as a backend, but I suppose it is temporary. When Relib is moving to Vulkan? Vulkan is still quite meant for huge projects. Yeah, OpenCL didn't work, and people also told me to not waste time with OpenCL. So I guess it makes sense. A bit of a teabagging. Well, I don't drink tea bags, it's only loose leaf. I kinda enjoy the loose leaf more. There's no taste of paper, even though if you regularly drink tea-bagged tea, you don't taste paper, you get used to it. I also like the process of preparing loose leaf. It's kinda meditation. Kinda like it. Kinda like it, kinda like it. There's some nice tasting paper out there. Who was that YouTuber who's like promoting coffee and stuff like that? James Hoffman? I think it's James Hoffman. He did a video where he tasted different fucking coffee filters. so fucking funny. It's so funny, like he literally took different coffee filters, like papers, steeped them in different like glasses and fucking tasted them. So fucking funny, I love it. What's the verdict? I don't remember. But he basically tried to like taste different brands, like how different brands are tasting. I love it so much. Do you use a French press or teapot or something else? I brew my tea in a different mug. I have a second mug, and that mug actually comes with a lid, right? And essentially I brew it there, and then I just pour it to another mug. The reason why I do that is because the teapots are pain in the ass to clean. They're absolute fucking pain in the ass to clean. I hate them. I absolutely hate them. When you brew in a separate mug, cleaning them up is basically rinse. That's it. So fucking easy. It's just like, it's insane actually. And I actually brewed tea for a very long time. I tried so many different techniques, so many different vessels. The only one that is actually convenient and quick to clean is another mug. It's actually kind of insane. So it's kind of insane. I wish there was like mugs that were just like, there is a thing where I could pour it easily, but I don't know. Utah teapot doesn't suffer from this issue. It has no bottom. Really? Okay. So, let's continue. So, chat told me famous last words. I'm not sure how much I want to trust the chat, but chat told me that validation layers are important. Right. They told me that they are important. However, that doesn't mean that these checks can't be added to API. Vulkan introduced an elegant... Okay, so we already read that. Okay. These validation layers can be freely stacked to include all the debugging functionality that you're interested in. You can simply enable validation layers for debug builds and completely disable them for release builds. So it's something that you do outside of the code, right? So if I understand correctly. Not really, right? So there is you have to have an array of validation layers which are strings. So you can actually fuck up enabling validation layers if the string is incorrect. Do I understand correctly? So is there any validation for the process of setting up a valid... okay. All right, see, fine. Classic, I know. Classic. So VK layer Chronos validation. Can I just maybe just enable that? I don't fucking know, man. So this is the validation layers I want. Not the validation layers I deserve, but the validation layers I want. And we can enable or disable validation layers through debug information or not debug information. I don't fucking know. So we'll add a new function, check validation layers. Because maybe we don't support a particular validation layer. So here comes the process of validating the setting up of the validation layer. Valik, what's up? So remember the Vulkan stream series? It's kind of like Handmade Hero, but for GPU programmers. And he found quite a few bugs in validation layers themselves. Okay. I'll need a function that checks if all the requested layers are available. So first list all the available layers using VK enumerate instance. Oh my god. Okay. Do I really need to do that, chat? Like okay, like I feel like I'm look at this fucking article. Look at this fucking article. Like I don't want to do that. Can I just continue? Can I just continue? And basically, if I encounter some bullshit, only then I go back to validation layers and enable them. Yes, it's long, but debugging errors is longer. Here's the thing. As soon as we encounter errors and bugs, I will go back to validation layer section and we'll set them up. Deal? And if you say it is as bad as you say, right? So we'll encounter some bullshit fairly quickly, right? You won't understand it's an error first. Well, if you can't tell, listen, guys, you don't understand. We're living in the age of AI and slop. If you can't tell, does it really matter? Look at all of the AI bros shaking out like a 10k lines of code that barely work and break. Like, does it matter in the age of AI slop? You can't tell it's an error at first. Who cares? Nobody gives a shit. Broski. Okay, but here's the plan. Because I feel like I need to get closer. Right. I need to get closer to acquiring the physical device and so on and so forth. Furthermore, we're walking the tutorial path. The tutorial has already, checked and validated everything for us, right? So this sort of like a happy path will probably fine. I don't fucking know. But anyway, so let's try to acquire physical devices. Hey Grok, make Vulkan validation layer, make no mistakes. Yeah, exactly. Okay. So VK physical device, VK null handle. Okay, let's take a look at the physical device, chat. Let's take a look at the physical device. Yeah, I would not trust the tutorial 100%. It's like, come on. People trust the AI generated code blindly, right? It's fine. It's fine. It's fine. In the age of AI slop, it's fine. Don't worry about it. Don't worry about it, chat. Don't worry about it. As the tech CEOs say, you guys are lost in the details. Safety, correctness, Guys, you're lost in the details. Ship, value for shareholders. Where is the value for shareholders? None of that bullshit, please. Anyways, well, let's take a look at it. Okay, so this is a physical device. Can we put like a semicolon? There's no physical devices in here. Fascinating. I wonder if it's one of those things. Yeah, it's one of those fucking things. It's a opaque motherfucker. Non-dispatchable handle. Look at that. So there's dispatchable and there's non-dispatchable handles. Okay. Non-dispatchable handles. That's kind of interesting, actually. That's kind of interesting. So what's that? Oh, there's two kinds of them, actually. VK define non-dispatchable handles. It's 64. I know what the fuck it is. That's so funny. You guys know what the fuck is this? So essentially, if it's dispatchable, it probably has this S-type fields with enumeration. If you make it non-dispatchable, it turns it into opaque 64-bit integers, so you can't even acquire its thingy. It's kind of funny, actually. So you can just, you know, pick whether it's going to be dispatchable, non-dispatchable. Okay, let's fucking go, man. Fucking go. Yeah, so VK physical device, and we can even do VK null handle. I want to take a look at what the fuck is VK null handle. It's probably like 0 or whatever. It's probably 0 or whatever. So it's probably define. It's probably something like that. Yeah, it's a null pointer depending on what kind of language you are using. Cool. So we're creating the physical device. Okay. And I probably want to put this stuff in here. Honestly, I want to destroy anything, right? So the operating system is going to do all of that for me. So the next function we're interested in, I feel like I'm Slavoj Žižek. Basically, Vulkan. Okay. So now we're going to just do something like that. Here is the function, right? So, and we have to do this same sort of trick. We have to do this same sort of trick where, yeah, we have to provide the instance, right? So here's the instance, and basically physical device count, and it's u in 32. All right, so we have to grab that. So physical device count. And we will have to provide the pointer to, well, we have to provide null, but I also want to look up how this thing is defined. What is this structure? So what kind of stuff we even have in here? Fuck. Don't tell me that it is a, well, I mean, it is opaque. It is, yeah. It is opaque. It's kind of interesting. So, okay, I see. Oh, that's interesting. Since it's opaque, how the fuck do I know its size then? It's very interesting. Yeah, physical devices, and I suppose it does have size, even though it's basically, well, it's size of the pointer, isn't it? Right, it must be size of the pointer. So there is an indirection layer. So we're going to be allocating an array of pointers, right? So since it's a handler, right, it's just opaque pointer. So what we're allocating an array of pointers. All right, okay, so it's just like a little bit confusing at first, but I see what's going on. All right, so this is instance, physical count, and here we'll have to put a null in here. Let me find assert. So this is assert, and then we're going to be mallocing this entire thing. So this is already picked physical device, and this is physical devices. Right, I'm going to be mallocing this entire thing, size of this thing, which is dereferenced, obviously. We're multiplying it by this entire stuff, right? So, and obviously we want to make sure that this thing was successfully allocated. That's very cool. Then we need to call this one more time. One more time. And we can maybe print something like. So physical device count. So here it is. So 8, put it in. I over copy pasted some code, chat. It's fine. It's fine. So I'm gonna put this stuff in here. So this is that, and let's just try to run it. How many physical? We found one physical device. Probably one GPU. That's literally probably one single GPU. That's what it is. So, and since physical device is opaque, there should be some functions that accept physical device and let me inspect its property, because I want to take a name of this thing. Can I take a name of this thing? So here's the physical device. I'm gonna literally grab who uses this. Oh my god. Okay. All right. So. Okay, vk get physical device. Okay, so there is a genre of functions, vk get physical device features. You can acquire its features. Oh, you can also acquire its properties. Okay, this one is interesting. So I'm interested in this specific function. Is that a good function? Chat, is that a good function? So then we provide the physical. We might want to actually iterate all of them. So physical device count. This is a physical device count, and for each physical device count, we have physical devices. Physical device, and it's something like that. It's excuse me, and we have to allocate a structure on the stack. All right, so let's give it properties. Let's zero initialize it just in case, and let's put it like that. So this is properties pointed to that. It never fails, from what I can tell. Right, so it never fails. It just acquires the thing. And now here is the fun question. What the fuck is this structure? Can anybody tell me? What the fuck is this structure? I wonder if one extends another one. I suppose, yeah. Okay. All right, this is interesting. So we have API version, driver version, vendor ID, device type, device name. This is what I'm interested in, actually. We need version 3, yeah, sure. Okay, so I'm gonna okay, I'm gonna put it like that. Can I? It fucked up, chats. It fucked up badly. But anyways, so what I'm interested in is the device name, right? So let's go ahead and just print the name. So what's that name? Properties. Name. Device name. Device name. All right, so let's try to do that. Physical devices. Okay. I don't know what these things mean. Radv Renoir, but we got a AMD Radeon graphics. Is it a good graphics card? Is it a good one? I don't know. It's just like this is the one comes that with my laptop. Yeah. Yes. Thank you so much. All right, that's pretty cool. So this is a device thing, and I suppose one thing we can do. We can just basically check. We can assert that this thing is equal to 1. Right, that's what we're asserting, and we are assigning the current physical device. We don't even have to assign it, honestly. Why do we have to assign it? You know, I've got an idea. We are querying the amount of devices, and we're instantly asserted that it is 1. We do not allocate any shit. We allocate this motherfucker on the stack. Then I'm passing, you know, the pointer to the one single physical device to that, and that's it. So why allocate anything, right, if you explicitly expect a single one? So it's just like it's the easiest thing to do here. Obviously, it's not going to work on every machine, but our goal is to just like, you know, get something working. So, right, what do we have? And physical, well, yeah, so we don't need that stuff anymore, though we can, we don't need that. Where was that? Yeah, so this is what we need. Detected graphics card. It's this one. What else? Properties. The different. What the fuck are you saying? Did I forget something? Hey. Wait. Ah, fuck. So we have extension properties, and now, okay, I see. Well, I mean, we can always just shadow it, whatever. Yeah, physical devices, right? So physical device, a single physical, there we go. Detected graphics card, AMD Radeon graphics, blah, blah, blah. Cool. So let's continue reading this entire shadow. So we enumerating physical devices. So we also... Is device suitable? Return true. Okay. And check. Okay. So physical device equal null. Base device suitability checks. Okay. You get device properties, right? So you check device properties, and then you check if it's suitable. Get physical device properties. Physical device type discrete GPU. This is not bad, by the way. We can add that to validation because we already kind of do have this validation, right? So we're checking that it's a single device, we get the device, we get its property, we get its name, and we do properties. We can assert that. We can just straight up assert that. Another interesting thing they're checking for is geometry shaders, but do we care about that? I think what we care about is the compute shaders. So let me grab, yeah, so here it is. I don't see, right, device features. Ooh, you need to have device features. Let's query device features, chat. Let's query device features. Yeah, where is that? So here is the device feature query. And this is what we're gonna do in here. So this is a physical device. Physical device. And the physical device features are, do you have compute? No. You do have geometry shader, right? Maybe it's comp. Chat, what's the field for compute shaders? Does it even have one? How do we know? I want to copy paste this. There's a lot of things in here, actually. Compute, comp. It's only compression. Man, this sucks. Work group. There's no work group in here. You have to query compute queue later. No, I have no idea. Like, I mean, I know nothing about Vulkan, so it's kind of weird that, okay, geometry shaders, you can check for them with just a feature, but then where's compute shaders then? Or is that they're from different category? You check what queues are available if the device has a compute queue. Okay, why, like, I'm pointing out not like at the discrepancy, right? So why geometry shaders are just field, but compute shaders is completely different thing. So kind of weird. Inconsistency. I'm pointing out inconsistency. But anyways. So pick physical device. This is a physical device. Rate device suitability. Oh, rate. So there is a rate. Oh my god. Do you guys see what's going on here? It's a multi-map sorted by score, and you come up with a cost function to pick a fucking suitability. And how do you rate suitability? Oh my god. This is so funny. Is this common in computer graphics? Is this shit like that common? It's like it's purely based on vibes. Yes, it is. Holy okay. Can you come up with a neural network that you can feed the properties of the properties and features of the physical device, and it gives you the score, right? So you can train some sort of AI model that picks a device for you. It's used for pick best compute device, yeah, I guess. So properties, physical device type, disk. Oh, you do this kind of thing. So you just pick a different sort of properties and stuff like that, and you do this social score thing. We have only one device, so we probably don't care. You don't need to implement all that for this tutorial, but it's to give you an idea of how you could design your device selection process. Of course, you can also just display the names of the choices and allow the user to select. Pretty interesting. So you're using the user's brain as the scorer. Can you RLHF? Bro, fucking listen. You create a game, right, where you display to the users, like pick your GPU. You send that information to your service, and you use that for human-assisted reinforcement learning to build a model that then automatically picks GPU, and then you ship that model to everybody, right? So users, by picking the GPUs manually, train the score model for picking GPUs. It's fucking genius. You can probably raise some money for a startup that does this kind of shit. So at first, it's like with CAPTCHAs. You know, you've seen the CAPTCHA, like select all the buses or select all of this is basically that. They're selecting GPUs, they're training the models for picking the GPU, and then you ship the model back to their machine so it automatically picks for them. So genius. And you can say it's AI, so that means you can raise some money for that, right? So so Q families. All right, so we got to the Q family. It has been briefly touched upon before that almost every operation in Vulkan, anything from drawing to uploading textures, requires commands to be submitted to a queue. There are different types of queues that originate from different queue families, and each family of queues allows only a subset of command. For example, there could be a queue family that only allows processing of compute commands, as you guys mentioned, right? So you just check availability of the compute queue. Or one that only allows memory transfer related commands. We need to check which queue families are supported by the device and which one of these supports the commands that we want to use. For that purpose, we'll add a new function, find queue families, that looks for all the queue families we need. So right now we're only going to look for queue that supports graphics command, so the function could look like this: logic to find graphics command. Respond only with code. Don't explain anything. Implement this function. Easy. So get physical device queue family properties is right. So fuck me. Where am I? Vulkan. What's that? I didn't copy paste that properly. Queue family properties. Grep rn. Let me take a look at some of that stuff. All right, so here are all of these stuff. So this is a CPP, so C is probably there at the bottom. Get physical device queue family properties. Yeah, so you can have a bunch of queues, and here's the VKQ family property. Honestly, like every time I grab something, I end up in Vulkan core. I think I should stop grabbing things. So VKQ family properties, right? So, and it's there is queue flags, queue count, timestamp valid bits, min image transfer granularity, Jesus Christ, and VKQ flags. Okay, so this is just VK flags, but here they are. So graphics bit, compute bit, there's so many bits. Bit, transfer bit, sparse binding bit, protected bit. I'm so fucking sorry, but yeah, I'm getting a little bit tired, so yeah. Cute family properties, yeah. So device creation flags and so on and so forth. All right, so I really like how explorable all of that is. Right, so it's just like you querying this stuff. Okay. So how in one of the next chapter we're already going to look for yet another queue, so it's better to prepare for that and bundle the indices into a structure. Queue family indices. Okay. What? What is all of that? Like this? I don't care about any of that code. It's just like some boilerplate for some sort of a future. How do we get? Okay, so this is the basically whatever Clunker actually told us, right? And let me see. So I suppose what I'm interested in is the queue that has the compute bit, right? So that's the one I'm interested in. So the process of retrieving the list of queue families is exactly what you expect. Uses this thing, right? So it is using this thing. We get a queue family count. We get all of the queues. We check which one has a graphic bit, and then yeah, we just do all of that stuff. All right, so the only, by the way, useful information is this code. The rest of the stuff is just kind of boilerplate. Well, I mean, maybe this particular thing is also a little bit useful. Boilerplate battle JDK versus Vulkan. What's interesting is that this tutorial adds its own boilerplate as well, right? So, which is kind of interesting. Which is kind of interesting. Where is the VK begin VK triangles? Yeah, I know, right? Classic. Oh, so yeah, Vulkan core is pretty much the whole API. Yeah, so I've already figured. Only platform specific stuff is in the other files. It's rather convenient. So it's basically like a jail.h. VK begin queue. Yeah. So VK begin. There's a command buffer, so you have to set command buffer. And what is a command buffer? It's a handle. Okay. How do I create command buffer? Is that, yeah, okay. Well, I suppose you begin it, right? So, but maybe there are some other places where you can create command buffer. So you begin, command bind. Okay, set blah blah blah, cmd draw. Yeah, there's a lot of functions that accept command buffer. There's quite a few of them. Right. It's pretty convenient that you can just look at all that stuff. You also, yeah, you need command pool and stuff like that. But first we need to actually create like a queue family. We haven't gotten to the point where we need to create a command like a queue family. So where is that function? Okay, so physical device, queue family. I wonder if we can kind of automate that pattern of looking up things. I wonder if we could, but I don't think it's that easy, right, to automate all of that stuff. So let's give it a try. So this is a physical device, right? So this is a physical device, and our physical device is that. Family property count, UN32, family property count. It's going to be this one. pointer family property count and okay properties. So here's a bunch of things. So we'll need them later. We'll need them later, and I'm going to put null in here. Look at that. Fuck. So it doesn't even return any failure, right? So it cannot fail, which is interesting. All right, so so family properties, malloc this stuff, and we probably want to do size of and multiply this scheisse by the family properties count. That's what we want to do. Assert that this thing was allocated properly. Call this one more time. One more time. So family properties count and like this for each individual family properties. So we have Q flags, minimal image. Yeah, so what I want to do, I want to just like print them. Q families like that, and we're gonna have, I suppose, something like U, and how much is that? So it's gonna be 4, 8, right? 0, 8, and it's gonna be X. Right, so I just want to see in hexadecimal, and then family properties I Q flags. And what's interesting is that there is also Q count. Let's do Q flags and just like observe the Q flags. Let's observe the Q flags. What else do we have in here? So what do you want? Oh yeah, wait. Get physical device features. Oh yeah, so it's a leftover from the previous attempt. That's fine. Okay, so that's great. So it's not a discrete GPU. It's not a discrete GPU. It's actually integrated one. So do we have any other things? Yeah, it's integrated one. All right. Now we know. Who needs validation layers if you have assert, chat? You don't need validation layers. Thank you so much for the sub. So I missed a couple of randomer. Richard Ware, thank you so much for the Prime. Oli Vervik, thank you so much for tier 1. DX Johnny, thank you so much for the Prime. Thank you. All right, so there's a bunch of flags and stuff. We also so Q count. Let's take a look at the Q count. Q count, and this is going to be something like that, but it's more of a like U family property, and this is a Q count like that. Q count, interesting. So I'm not really sure what exactly does it do, but we want to probably look for the one that has compute, right? We want to look for the one that has compute. So we take Q flags, compute bit. So and essentially, if let's grab this thing, Q flag, is it set? All right, so there's only two things in here. Two Qs, 1 and 4 with the compute flags. That's very cool. So here for the graphics bit and the one for the compute bit. All right. So logical devices and queues. Cool. Logical devices and queues. After selecting a physical device to use, we need to set up a logical device to interface with it. So the logical device creation process is similar to the instance creation process and describes the features we want to use. Understandable. We also need to specify which queues to create now that we've queried which queues families are available. You can even create multiple local devices for the same physical device if you have varying requirements. I'm telling you, they just simulating Amazon services. Start by adding a new class member. Well, I mean, okay, whatever. So what we're doing, find Q families, right? So we find a bunch of Q family indices, all right. So VK device Q create info, right? So family index. This is interesting. So I have to, I think I understand what is going on here. So we have to pick the Qs. We have to put them into the array of indices, and this is what this Q family index was about. Right, that's what it was about. Yeah, so Q family indices, and it's only like, yeah, that's weird. Logic to find Q family indices. Why is this only one thing in here? Are they like packed into the field or what? Not. That is kind of a bit bizarre. It's kind of a bit bizarre. I'm gonna sneeze, by the way. Q count. It's set to. I see what's going on. It's set to 1, so there's only one index in there. Fuck me. Jesus Christ. So find Q family indices, and this was implemented in the previous chapter. Let's go to the previous chapter. Yeah, and it was not implemented. It was literally not implemented. Local devices and queues. Chat, I'm already tired. How close are we to compute something on GPU? So in percentages. Not even close. We're not even, but I don't know you, I don't believe you. 12%. I also don't know you. So I'm looking for somebody who knows what they're talking about. Okay, I suppose all of the people who know what they're talking about left. All right. So no idea, yeah. So we just need to create a logical device, and yeah. So we can get Q and retrieving Q handles, and there you go. We should be able to finally get the Q. Finally get the Q. We're almost done initializing. So it's 2.5 of an hour. I'm just like not sure what to do. Do I continue or do I do another stream tomorrow? I think I need to do another stream tomorrow, right? So because I'm kind of getting tired, right? So I'm kind of getting, well, falling asleep. So I think I'm gonna split that into 2 sessions. Well, 1,100 people are watching this. Well, I mean, but I'm tired, so let's split it in 2 streams, right? So I'm gonna continue tomorrow. Tomorrow, hopefully, we'll achieve the compute shading, and yeah, on YouTube, I'm gonna upload the combined session, right? So it's gonna be a combined session. Then next stream, yeah. That's it for today. Thanks everyone who's watching me. I appreciate that, and I see you all tomorrow, right? Tomorrow we're gonna continue and hopefully achieve the compute. All right, love you. Mwah.